So good evening, everyone. This is lecture number 4 in photoelectric effect, and we are dealing with the effect of potential on the photoelectric current. We had seen the 2 or 3 points. Anyone remembers those points? Do we remember these points? What happens when you change the potential difference? What happens on the current? When the
Yes, sir.
potential is 0, we'll see some current flowing in the circuit, but that is of no importance. Yes or no?
Yes, sir.
Then we see that if you increase the potential of the anode with respect to the cathode, then you will have more and more current flowing. Yes or no? At one
Yes,
stage,
sir.
you will have maximum current and it will not increase from that stage. We had discussed this point also. Yes or no?
Yes, sir.
Yes, sir.
Now, that is the next definition that is going to come for us. What is that definition? That definition is the definition of saturation current. What do you mean by this saturation current? Anyone? What do you mean by this saturation current? Anyone knows the definition? We have already seen this definition. Yes or no? So you can write it down. Saturation current. Write the next heading, saturation current. What is saturation current? When all the electrons which are emitted by the cathode, they reach the anode, the current becomes constant. That current is known as your saturation current. You see this, bacha? Yes or no? Here what happens, the electrons which have even kinetic energy 0, they are reaching the anode. Whatever electrons are emitted by the cathode, each and every electron is reaching the anode, and that is why you have the current becoming constant. One more thing, I mean, Tanaka Center, are you there or have I lost you? See you, what's the problem? Okay, yeah, now I can see you. So there are points that we had noted here and we'll note them again. Saturation current. Saturation current is the maximum current that flows, and it happens at 1 voltage, and at that given value of voltage, after that current will not change because all the electrons that are emitted are reaching the anode. Do we understand this?
Yes, sir.
Okay. We have seen what happens when the potential is 0. We have seen what happens when the potential is 0. Yes or no? Some current flows. Nothing happens from that current, but some current flows. We have also seen what happens when the anode is made positive. Now, what are we going to do next is going to make anode
Sir,
negative. Yes, beta?
one second repeat, sir.
What happened, beta?
Sir, 1 second repeat, sir.
You're not able to hear me? Okay. Where were we? What do you want me to repeat? Tell me. From where? From which point?
Saturation current.
Saturation current. Where were you when I was teaching? Or you're not able to hear my voice? Is that so? Okay. So saturation current is the current which is the maximum current in the circuit. And why this maximum current comes? Because all the electrons which are emitted by the cathode reach the anode. Even the electron which has zero kinetic energy, when it reaches the anode, you have this saturation current. Current cannot increase from that value, no matter you increase the voltage. Do you understand this? That is your saturation current. We will see the graph as well. Now, what are we going to do next? Now, if the anode is made negative with respect to the cathode, what will happen? If I make it negative, the photoelectric current will start to reduce. Yes or no? When I was increasing the voltage, making it more and more positive, photoelectric current was increasing. If I decrease the value of this potential, make it negative, the photoelectric current is going to decrease. Yes or no? We understand this? It will keep on decreasing, it will keep on decreasing, and at some point that photoelectric current is going to become zero. Do we understand this?
Yes, sir.
That potential is known as your stopping potential. At a certain negative potential, the current will become zero. This is known as the stopping potential, and the stopping potential is written as V naught. Now, what happens at the stopping potential? The electrons with maximum kinetic energy are not able to reach anode. Even if the electrons which have the maximum kinetic energy, it is not able to reach anode, and therefore we have this formula for this maximum kinetic energy. Maximum kinetic energy is E multiplied by V naught, where E is the charge of the electron and V naught is the stopping potential. What all we can understand from here is that the kinetic energy of the electrons which are emitted, it lies between 0 to a maximum value, and the maximum value of kinetic energy is nothing but E into V naught. Write it very carefully. Please do not make mistake. I am going to make you understand this in different ways. And if you don't understand it in English language, but you have understood it, you can write it in your own language. Doesn't matter. English doesn't matter. What matters is that you need to understand the concept. If you understand the concept, well, you don't have to do anything. So write it patiently. I'll give you 2 minutes. Once you are done, please let me know.
Done, sir.
Boys, girls, both? Okay. Now, since we have seen what happens when we change the potential, we are now ready to draw a graph. A graph between what and what? A graph between photoelectric current and your potential difference. Because we have seen, or we are seeing, the effect of potential difference or anode potential. So now we are going to draw this graph, and the graph looks like this. I have not named this graph so that I can name it in front of you so that you understand what are the elements in this graph. So here is the graph. What is plotted on x-axis and what is plotted on the y-axis? The anode potential is plotted on the x-axis and the photoelectric current is plotted on the y-axis. Do we understand this?
Yes, sir.
When you see that when the potential is 0, then also you have a very small current. That is this current. Then you see, if you keep on increasing the potential, at some point you will get this IS. You understand the meaning of IS?
Stopping potential.
IS,
Saturated current.
saturation current, the maximum current. Then if I make the potential negative, at some point you will have the photoelectric current stop. What is this voltage known as?
Stopping potential.
Stopping. This is the graph that we have explained in the previous class and also in this class. I'll give you 2 minutes to draw this. You understand the marking of this graph, yes or no?
Yes, sir.
This chapter is all about graphs. Remember it. Once you're done, please let me know, bacha.
Sir.
Girls, are you done?
Done, sir.
Boys, done?
No, sir.
Okay. Now here at this point, we must now take a pause and again revisit the concept that we have studied before. That concept is the concept of intensity and energy. Now, we had seen intensity in the last class. And if you remember intensity of a radiation, I told you intensity is the energy falling per unit area, per unit time. Yes or no? Now, here when we are referring to intensity, we are referring to the same intensity, but we must understand on what factor this intensity depends on. This intensity of radiations, which is energy falling per unit area, per unit time, it actually depends on the number of photons that are falling. Number of photons that are falling. If the number of photons n, remember n, is increased, that will imply the intensity of the radiation is increased. Do we understand this?
Yes.
If I allow more photons to fall on the surface, I will allow more intensity of light to fall on the surface. Do we understand this?
Yes,
Yes,
sir.
sir.
When we talk about this energy of radiation, now this energy of radiation does not depend on the number of photons, because this energy of radiation depends on the frequency of these photons. Do we understand this?
Yes,
If I
sir.
increase the
sir.
frequency of the radiation, that will imply that I have increased the energy of the radiation. To increase the energy of the radiation, I must increase its frequency. To increase the intensity of the radiation, I must increase the number of photons. That is the moral of the story. Have you understood the moral of the story? Yes or no?
Yes, sir.
What is the moral of the story? Intensity.
Number of photons increases, intensity increases, frequency increases, energy increases, sir.
Right. Remember this, because whatever questions you are going to encounter will be based on either one or either two. Now, again, we were discussing what effect does the potential have on photoelectric current. We will revisit the same diagram, same graph, but now we will be having different intensities of radiation falling on it with a fixed frequency of radiation. Now you can understand what happens if we have two radiations falling on the metal which have the same frequency but which have different intensities. Can anyone tell me verbally, orally? Let me just put it here. Let me see if I can put it here. Can anyone tell me verbally or orally how will the graph look? The graph looks like this. Now remember, here I have made two radiations fall. The frequency of the radiations are same. Frequency of radiations are same, but the intensities of radiations are different. One has intensity I2, this has intensity I2, and this has intensity I1. Can you tell me by looking at the graph, which one will be more? Is intensity 2 more or intensity 1 more? Which intensity is more looking at the graph?
I2, sir.
I2 is more because the current is more. But you can see they have the same stopping potential because frequency is same. Frequency determines your stopping potential, whereas intensity determines your maximum current. Do we understand this?
Yes, sir.
Okay. So I'll give you 2 minutes to note this. Let me know once you are done. Anyone having any doubt, bacha?
No, sir. Completed.
Shall we move ahead in life?
Done, sir.
Yes, sir.
Now, if I draw a graph between intensity and photoelectric current, so you can write the heading as variation of, I hope you can see this, variation of PEC photoelectric current with intensity I. Now, intensity means more number of photons. What will happen if I have more number of photons falling on this?
Intensity increases, sir.
No, intensity is what we are controlling. Photoelectric current is the effect. So if I increase the intensity, what will happen, bacha? The photoelectric current will increase. Do we understand this? Yes or no? Yes or no?
Yes, sir.
The photoelectric current will increase and you will have a graph like this. It is directly proportional to the intensity. The photoelectric current IP is directly proportional to the intensity, but this will only happen when the energy of radiation is more than work function, when your frequency is more than F naught, your lambda is less than lambda naught. If your energy is not more than the work function, electrons will not be emitted and nothing will happen. Do we understand this? Yes or no? No, yes.
Yes, sir.
So this is one graph. And the other graph we have already seen. So I'll just put that graph also so that you see, you understand that these are the two graphs that you will have to see for the variation of current with intensity. You understand this graph now? The right hand side graph we have already discussed. Yes or no? No, yes?
Yes,
Yes, sir.
Okay. I'll give you 2 minutes to note this down. Let me know once you're done, bacha.
Sir.
Yes, bacha.
Completed, sir.
Let me know once you're done. If you're done, please let me know. If you're drawn the diagram, please let me know so that we can move ahead.
done, sir.
Boys, only smiling or also writing?
Sir, said
Yes.
first only, sir. Completed, sir.
Yes. Okay, you had already completed. So we are waiting for the girls. Probably I did not see. The problem is I don't know why your mic I'm not able to hear. The other class I'm always able to hear speak and
I'm
see. You see half, I only listen to half and the other half I had to assume what you would have said. So it is all on assumption that I speak of. It's all assumptions that you would have said this. Not actually, I don't hear anything. Anyway, let us move ahead. And we were discussing the effect of intensity on photoelectric current. And we have seen this graph. Now the next thing is, since we talk about frequency, let us move on to that. So effect of frequency. Effect of frequency. In bracket, I will write energy of radiation so that we understand frequency refers to energy of radiation. Now, the only effect that you can write here is, number one, if frequency is less than F naught, there is no photoelectric current. Yes or no? Do we understand this? Huh?
Yes, sir.
If your frequency is greater than F naught, this virtually has no effect. Frequency virtually has no effect on photoelectric current. Then what does it affect? Frequency or energy, F or energy, only affects the maximum kinetic energy, which implies that it affects the stopping potential. That is the only effect frequency or energy of the radiation has. You can write this like this also, just to understand. If you increase frequency, which basically means you increase energy, or you decrease your wavelength, remember, this must be greater than the threshold frequency. Then your kinetic energy maximum increases. That again implies your stopping potential V naught increases. When I say stopping potential V naught increases, increase there does not mean that maths wala increase, -5, -2, which is more, -5 or -2? In maths we'll say -2 is more, but for us minus only indicates the polarity. -5 is more than -2 here in physics. Do we understand this? So if you increase the frequency, let us say for one frequency we have the stopping potential at -2. If I increase the frequency, the stopping potential will become more than -2, -3, or -4, or -5, and so on. Do we understand this?
Yes, sir.
For us, negative sign only means the polarity beta. It does not mean what it means in what, in that that maths. Do we understand this? And hence we can draw a graph between, which graph should I give you? That looks good. Have we noted this down?
Yes, sir.
You can draw a graph between stopping potential and your frequency, and the graph looks like this. The stopping potential increases. The slope of this graph, tan theta, is given by h by e, which probably we shall cover in the next class. I hope you see this, yes or no?
Yes, sir.
Okay. Now there could be one more graph that is drawn, and I take that graph from here only because I see this is a nice looking graph. Now this graph, my dear friends, is again plotted between stopping photoelectric current and voltage, but here the intensities of the radiation is same, but the frequencies of the radiations are different. This is frequency F2, this is frequency F1. Can you tell me which frequency is more and which frequency is less from the graph? Huh?
F2, sir.
Did you get this answer from yourself or with help from your classmates and roommates? We understand this? That is more important. You help each other. That is what companionship or friendship is all about. That you help your friends and your comrades. We call them comrades. You help your friends and comrades, but you must also understand yourself. Do you understand this? Yes or no? Your friends and comrades may not be there in the examination hall, and please do not nibhao your friendship in the examination hall, because then both of you would be caught and no one would be of any use to anyone. So it's only good outside the examination hall. Do you understand this, everyone?
Yes, sir.
One more thing that you have to note down is something known as time lag. Have you noted this down, everyone?
Sir, 1 minute.
Okay, I shall give you 1 minute. You can make Maggie in 1 minute. I can give you 1 minute for Maggie. For the sake of Maggie. Everyone loves Maggie. Hard to find a soul who doesn't love Maggie. 2 minute रुक सकते हैं. Just stop for 2 minutes for a Maggie. God help Maggie. Let me know when your Maggie break is over. Are we there? Or still having Maggie?
Sir, done, sir.
Had your Maggie? Okay. What about the boys class? Are we done?
Completed, sir.
Boys class also has a girl's voice now. So it's all girls everywhere. Good. Okay. The next thing, probably the last of the things that you have to remember is the time lag here. Time lag. Now, this is an important aspect of this entire discussion because there are 3 or 4 points which make us realize and believe that this is because of the particle nature of light and not the wave nature of light. And this is one of the things, time lag, and you might get a question straight away on this NEET. They'll ask you simple series questions, as simple as that. Time lag, there is no time lag. Hey, that means it's an instantaneous process. As soon as light falls, dadang, electrons are emitted, padang, dadang, padang, dadang, padang. That is instantaneous. This process is instantaneous. That's it. Note it down. As soon as light falls, electrons are emitted. So this gentleman is ready to give. Light fall, I'll give. So light falls, I'll give. That is how it happens. Note it down. And then we'll try to note everything down at one place. That is how I understand things. I hope you have understood the graph. You understood the graphs? We'll write everything together at one place. And whenever you have to revise, you can just go through those notes. I also told you to make notes, short notes. One more copy, short notes. Write everything there. So that whenever you have to revise, you can just look at the short notes and stay happy with those short notes. Let me know once you're done.
Completed, sir.
Completed, sir. Okay.
Done,
Shall we move
sir.
ahead in life? Okay. Let us go back. And we'll try to understand everything one more time, because you're not going to get literally any question from this chapter. You're only going to get theoretical questions from this chapter. First thing, photoelectric effect. When light falls, tarang, electrons are emitted. Photoelectric effect. Photoelectrons, the electrons which are emitted. Photoelectric current is the current which is established. Now, the first thing, and we will note them down from the very first day. So let us note all the important points of this chapter at one place. I will write them in very short. You will have to write them in the longer format or whatever. So important points, everything put together. Number one is work function, which is W naught or W, which is the minimum energy. We understand this? Yes or no?
Yes, sir.
That is equal to H into F naught. That is equal to HC by lambda naught. And I can find it out from what? 12,400 divided by Armstrong unit. Do we understand this?
Yes, sir.
F naught, threshold frequency. Frequency of radiation must be greater than F naught. If F less than F naught, no PEC. Yeah, also I'll write energy of radiation must be greater than W naught or W. Lambda naught, threshold wavelength. Lambda of radiation should be less than lambda naught. If lambda is greater than lambda naught, no PEC. So far, so good? Huh? We'll try to put it in everything here. Next point. Oh, this is the next point. I also forgot. Saturation current. IS, saturation current. Maximum current. Do we understand this?
Yes, sir.
It depends on what? It depends on intensity. Yes or no?
Yes, sir.
Depends on intensity. More intensity, more current. Next point. V naught. Stopping potential. Depends on what? Huh?
Frequency.
Well done. It depends on frequency F or energy E. Then the formula that we had seen, KE max is equal to E into V naught. We're getting there, no?
Yes, sir.
0 is less than equal to the kinetic energy is less than or equal to Ke max. The energy of the emitted electrons lie between this and this. Anything else left? Or I think we have done everything. I think we are done. Or I can add more points here. If intensity is increased, the photoelectric current increases. If frequency is increased, stopping potential increases. Do we understand this, or this has gone above our head saying bye bye? Bye bye, I'm going. Don't worry about me.
Sir?
Yes, bacha.
Sir, am I audible, sir?
Yes, you're audible. You're not visible but audible. Yes.
Sir, actually we have technical issue. We can't see you and we can't see your screen.
Okay. There is nothing that can be done now. Okay, and anyways, we are done with the class anyways. So what we'll do is we'll continue with the class in the next one. Okay.
Okay,
Okay.
sir.
We are done with I'll not write anything on the screen. So what we have discussed is the effect of various factors on the photoelectric current, the effect of potential difference on photoelectric current, the effect of frequency, and the effect of intensity. We will go ahead with these topics in the next class, and probably in the next class we'll wind up this topic. So if you have any problems, please come up to me. Else we are done with this class. Take care. God bless all of you. If you have any problems, come up. Bye bye.